Imagine a single, elegant idea that could explain almost everything about our planet. What if it could explain Earth's gravity, internal heat volcanoes, magnetic field climate? This is the promise of the quantum black hole at Earth's core theory, QBH C. Instead of a solid iron ball at Earth's center, imagine a tiny, ancient black hole. Not sci-fi, a bold claim trying to unify geology and physics. When an idea promises to rewrite textbooks, it deserves our attention. We have to kick the tires. We have to see if it holds up. Science loves simplicity. One explanation replacing a dozen is powerful. Think Newton, apple falling moon, orbiting. QBH C aims to do that for our planet. It claims the central black hole is the source of Earth's gravity. It claims it generates heat by consuming matter. It claims its spin powers our magnetic field. A compelling grand narrative. But story alone isn't enough. Every claim must face evidence. It must obey the laws of physics. First, let's talk about gravity and black holes. Albert Einstein's theory of general relativity tells us that gravity isn't a mysterious force. It's a curvature, a warping of space-time caused by mass and energy. The more mass you pack into a small space, the deeper the curve. Earth versus black hole curvature. A black hole is what you get when you warp space-time so much that it creates a one-way street. Its gravity is so intense that once you cross a certain boundary, the event horizon, there's no turning back. Not even light, the fastest thing in the universe, can escape. This is a fundamental rule of the cosmos. But there's another crucial rule, discovered by the brilliant Stephen Hawking. Black holes are not completely black. They have a faint glow, Hawking radiation. This radiation causes the black hole to lose mass and eventually evaporate. The smaller the black hole, the hotter it is, and the faster it evaporates. This is a direct consequence of combining quantum mechanics and general relativity. Think of it like a tiny, leaky cosmic balloon. Small balloon, higher pressure, leaks faster. Tiny black hole, radiates furiously. Giant one, barely whispers. The QBH C theory faces what I call the Goldilocks problem, but with a twist. None of the options are just right. Let's explore the three possibilities for the mass of this hypothetical black hole. Small, very small black hole. Medium, a medium-sized black hole. Third, a pre-existing black hole containing Earth's mass. First, imagine the black hole is very small, just above the minimum mass needed to survive for billions of years. A small black hole is an incredibly hot black hole. It would radiate energy with extreme intensity. Hawking radiation from such a hole would have sterilized our planet from the inside out. Life could never have begun, let alone evolved into us, like trying to build a house next to a continuously exploding nuclear bomb. Okay, what if we make the black hole bigger? Let's try a medium-sized one. A more massive black hole would be cooler and radiate less. But we get a new problem: gravity. A black hole is a point of immense gravitational attraction. It would begin to feed on the surrounding matter of Earth's core. As it consumes matter, its mass increases. That increases its gravitational pull, which lets it consume matter even faster. This creates a runaway feedback loop. The black hole would grow exponentially, devouring our planet from within. Earth wouldn't have lasted 4.5 billion years. It would have been consumed in a geological blink. Small is too hot. One of the central claims of the QBH C theory is that the black hole generates Earth's internal heat. The proposed mechanism is that as matter falls toward the black hole, it gets jammed up, creating friction and heat, similar to how a clogged drain can cause water to back up. This heat, the theory argues, is what powers volcanoes and drives geological activity. It's an interesting analogy, but, it runs into a wall of contradictory evidence. We have measured Earth's heat flow very carefully, all over the globe, and we have a very good understanding of where that heat comes from. It's not a mystery waiting for a black hole to solve it. The vast majority of Earth's internal heat comes from two main sources. First, there's leftover heat from the formation of our planet 4.5 billion years ago. The collisions of all those planetesimals and asteroids generated an enormous amount of energy, and much of that energy is still trapped inside, slowly making its way to the surface. Second, and more significant source, is the radioactive decay of elements like uranium, thorium, and potassium. Uranium, thorium, potassium. These unstable elements act like tiny, slow-burning embers, releasing a steady stream of heat as they decay over billions of years. We can measure the amount of these elements and calculate the heat they produce, and it matches the observed geothermal flux almost perfectly. Furthermore, the QBH C explanation for volcanism just doesn't align with what we see on the ground. Volcanism isn't random. It occurs in very specific places for very specific reasons. Most volcanoes are found at the boundaries of tectonic plates. Our planet is wrapped in a protective magnetic field, a shield that deflects harmful solar wind and cosmic rays. Without it, our atmosphere would be stripped away, and life on the surface would be impossible. The QBH C theory proposes a simple source for this field: the black hole itself. If the black hole were spinning and had an electric charge, it would act like a gigantic dynamo, a central rotor generating the magnetic field. This sounds plausible at first, like the spinning alternator in your car. However, this picture contradicts a key feature of Earth's field: it flips. Geological records in ancient lava flows show, with undeniable clarity, Earth's magnetic poles have swapped places hundreds of times. These magnetic reversals are not regular. They happen at chaotic, unpredictable intervals. A spinning solid object like a black hole would produce a very stable magnetic field. Its axis of rotation would be fixed over billions of years. It couldn't just spontaneously reverse polarity. Imagine Earth's axis flipping so the sun rises in the west. A spinning black hole core is physically unable to produce the observed flips. It's too stable, too rigid to explain the messy, chaotic behavior we observe. The Geodynamo theory perfectly accounts for this chaos. The QBH C theory makes one final sweeping claim that heat from the central black hole is a major driver of Earth's climate and ocean circulation. It suggests internal heat creates geothermal-driven currents more significant than the sun-driven currents we learn about in school. And this is one of the easiest parts of the theory to test because we've measured Earth's energy inputs with incredible precision. We know exactly how much energy we get from the sun. We also know how much heat flows out from Earth's interior. It's not a fair fight. The sun wins by a knockout. Let's look at the numbers. The sun bathes Earth in about 173,000 terawatts of power. That's a 173 with 12 zeros after it. This solar energy warms our atmosphere. It drives our weather. It powers photosynthesis. It creates the wind. In contrast, heat from Earth's interior is about 47 terawatts. So, we have journeyed to the center of the Earth, armed with the laws of physics and decades of geological data. We've examined the quantum black hole at Earth's core theory from every angle. We tested its claims about gravity, heat magnetism, climate, and in every single case, the theory comes up short. It's a grand and fascinating idea, but it wilts under the bright light of scientific scrutiny. It proposes a single object that would be too hot, too unstable, or fundamentally incompatible with how planets are born. It doesn't align with what we know about the laws of nature: plate tectonics, geodynamo, radioactive heating, solar energy. Earth's gravity is perfectly explained by its distributed mass, measured precisely through seismology. Its inner fire is accounted for by primordial heat, radioactive decay. The dramatic dance of our volcanoes and mountains is elegantly described by the theory of plate tectonics. The chaotic, flipping magnetic field is a natural outcome of a churning liquid metal core, the geodynamo, and our climate and oceans are overwhelmingly powered by the single greatest source of energy in our neighborhood, the sun. We don't need a black hole to explain these things. Science is not about finding the most exciting or exotic story. It's about finding the explanation that best fits the evidence. The QBH C theory is a square peg trying to fit into a series of round holes. It creates more problems than it solves, requiring us to ignore fundamental principles of physics and discard mountains of geological data. The established theories form a coherent, interconnected, and powerfully predictive picture of our world. They are the result of centuries of observation, calculation, and debate. They work. For those who want to learn more about the established science of our planet's interior, I would recommend starting with foundational texts and reviews on geophysics and planetary science. Treatise on geophysics review articles in journals like Nature Reviews, Earth and Environment. The QBH C theory, while imaginative, simply doesn't have that evidence. It remains a speculative hypothesis that is not supported by the facts. In the end, the search for knowledge requires us to be open to new ideas, but ruthless in our demand for evidence. The evidence is clear. Earth's climate dances to the rhythm of the sun, not a hypothetical drum at the core. We don't need a black hole at Earth's center to explain gravity, heat, magnetism, or climate. Our established models already do. Tested, verified, predictive. That's the power of science. Thanks for watching.